today in class we were looking at 102, and we kind of ran into some problems here, but everything we had done in class was correct. So on part B there, we had the sine line, and we had pi over 6 and 3 pi over 4 and 5 pi over 6. And the key I had posted had some extra stuff that was unnecessary and one piece that was incorrect. So I will repost that correct response there for you as well. If you look back at the new solutions, they'll be correct. So we found that this was positive. Then we plugged in 5 pi over 6. So f prime of 5 pi over 6 was 1 plus 2 times the sine of 5 pi over 6 times the cosine of 5 pi over 6. And we did this in class, and we had 1 plus 2 times 1/2 times negative square root of 3 over 2, which we said gives us 1 minus the square root of 3 over 2. And this is still positive. So on my original, that sign was wrong. That should be a positive there. So what this tells us is that f prime of x is always positive, or 0, between pi over 6 and 5 pi over 6. So we would say since f prime of x is greater than or equal to 0 on pi over 6 less than or equal to x less than or equal to 5 pi over 6, f of x increases on the entire domain. Therefore, f of x must have a minimum at x equals pi over 6. Because if the function is increasing on its entire domain, then the lowest point has to be that starting point. So this gives you your answer. So x equals pi over 6 is your absolute minimum. We should put absolute minimum for this function. So for part C, what was on the solution for part C was correct, but I have noticed that there is an easier way to do the problem, so I'm going to show you that way here. So f prime of x is 1 plus 2 sine x cosine x. And in the last problem, last part, we changed 2 sine x cosine x to sine 2x. So let's do that here. It makes it easier. It makes it easier to find the derivative. Because if we use this function, we have to use the product rule to find the derivative. If we just use this one, then we don't. We have to use a chain rule, but it's a pretty simple chain rule. So when we take the derivative of this to get the second derivative of 1 is just 0. Derivative of sine is cosine, so we'll have cosine of 2x. And then we have to multiply that by the derivative of the inside, which means we just need to multiply this here by 2. So our second derivative is 2 cosine 2x, which is a little bit easier to deal with than if you use the product rule here. So to solve this, we want to see where this equals 0 to get our critical point. So that really just means cosine of 2x equals 0. And if we think about the unit circle, cosine is 0 at pi over 2 and 3 pi over 2. So 2x equals pi over 2 and 2x equals 3 pi over 2. we would solve both of these for x, so we would divide by 2, or I'm going to multiply by 1/2. So I get x equals pi over 4, and then multiply by 1/2, so x equals 3 pi over 4. So we get these two critical points here. We're going to make a sign line with this. So we've got pi over 6 is the beginning of our domain. We'll have pi over 4, 3 pi over 4, and then 5 pi over 6. And we're plugging into the second derivative here. So between pi over 6 and pi over 4, there are no values. But let's go ahead and use pi over 6, because pi over 6 is at the end of our domain. It's not a critical value. So it is something that we can plug in here. So use the right derivative. Second derivative is 2 cosine x 2x. So we have 2 cosine of 2 times pi over 6, which is 2 cosine of pi over 2. And cosine of pi over 2 is, it's not pi over 2. This is going to be 2 cosine of pi over 3. Cosine of pi over 3 is 1/2, so that gives us 1, which is a positive number there. If we take f double prime of a number of value between pi over 4 and 3 pi over 4, the easiest to use is pi over 2. We'll have 2 cosine of 2 times pi over 2. That is going to give us 2 cosine of pi, and cosine of pi is -1, so 2 times -1 gives us -2, so we get a negative in between pi over 4 and 3 pi over 4. And then let's check the second derivative of 5 pi over 6. So if we do that, we get 2 cosine of 5 pi over 6 times, there should be a times 2 right there, which is going to be 2 cosine of 5 pi over 3, and cosine of 5 pi over 3 is 1/2, which is going to give us 1, which is a positive number, so we get a plus here. So we have a second derivative that's going to change signs at pi over 4 and 3 pi over 4, and those are going to be our points of inflection. We have to explain that in our answer, so we will say since f double prime of x changes signs at x equals pi over 4 and x equals 3 pi over 4, f of x has points of inflection at these points. I have updated my solution so that this is reflected there, so you can look at that. That solution is much better. The old solution was